Hello and welcome back, and that's right, today I want to talk about a couple of things. Today I want to talk about the Synology DS1522 Plus with the 10 gigabit Ethernet upgrade, and I want to talk about the WD Red 22 TB Pro Series drives. And in today's video I'm going to run a whole series of tests on these drives in a RAID 5 configuration, utilizing different protocols and different RAID configurations to give you some idea about, one, the performance benefits of these drives once you hit the larger capacities, but also the performance benefits of using greater than gigabit network connections. And to give you a sense of perspective, I'm going to be utilizing two different main formats of connectivity. I'm going to be utilizing a 5 gigabit Ethernet adapter, and I'm going to be using a 10 gigabit Ethernet adapter. But before we go any further, a few disclaimers straight off the bat. First and foremost, although I've got the camera running right now, because a lot of the operations I'm going to be doing today are quite resource intensive with my localized system that we're going to be utilizing, the old Dreamcast stamped laptop that we use in the other videos, performance is going to be up and down. And when I know that some of the recording that I'm doing right now is going to impact those results, I'll let you know. Case in point, what I'm going to do right now while I'm talking to you is create a tunnel there with the NAS, and I'm going to talk through it in just a moment, and just begin a 256 megabyte Atto test there on a 5 gigabit Ethernet connection. We're just going to leave that running there in the background while I talk to you about the setup for today's test, and we'll return to that in just a few minutes. Now, as mentioned, we are utilizing a 10 gigabit Ethernet connection on the network there. We have got the original DS1522 1 gigabit Ethernet connection there, but we're also utilizing their E10G22 T1 mini adapter there to add a 10 GBE connection to this 5-bay NAS system. That 10 GBE connection there is connected to my local machine. So if we open up my network connections down here, you're able to see that at the moment I am running a 5 gigabit Ethernet adapter. If we go into the status of that adapter, you can see it's a 5 gigabit Ethernet port there. It's been running for about 5 minutes right now, with data being exchanged there as we're running that Atto disk benchmark test there at the bottom. Now, what you can also see, if we dig a little deeper in there, if we go into the properties, you'll be able to see that I've made sure to set jumbo frames, jumbo packets or MTU, to 9000, which is going to be really, really important there as we go. So again, we're going to set that in just a moment. We're just going to let those tests finish, and I'll come back to that in a moment. But while we move away from that, we can have a little look at those tests. As you can see, the MTU has already been set to 9000 there on the Synology via that 10 GBE connection there, but that 10 GBE connection as it stands is only connected at 5000 megs because of the adapter we're using. Later in the video I will be using a 10 gigabit to Thunderbolt adapter to show you the 10 GBE performance of these drives. Now let's talk a little bit about those drives, shall we? Now the drives themselves, ignore that there, that was when I was refreshing the page moving between the 1 and 10G connection. You're able to see there, if we go into the volume, I've created a RAID 5 storage pool there, and a volume on there occupying the full capacity. Now that capacity, as mentioned, is utilizing 4 drives there. Each of these drives are WD22 TB Red Pro drives there, with each one of them installed inside there. You can ignore the fact it says 20 TB there. They are the 22 TBs. It's just aggregating the calculation of bytes versus megabytes versus gigabytes versus terabytes in that mathematical calculation. You may also notice that I've got a couple of SSDs pre-installed in this system. I won't be utilizing those, and I've not enabled any caching, as you can see there. Now these drives are all lovely and healthy, everything's absolutely fine, and you can see I've already performed a benchmark on these drives from a previous video, and they're running sweet as. So we've got 4 of these drives. Each one of these is reported at around 240 to 260 megabytes per second each, and in a RAID configuration that should give us an advantage of between 80 to 120 megabytes per second increase per drive. But we also have to factor in that in this RAID 5 configuration we've got 1 disk of redundancy there being presented to us. So now we know about the drives, let's talk a little bit about the NAS system itself. And the NAS system itself, if we make our way into the hardware and power, Oh, actually, what am I saying? It's going to be in the info center. We can see that this is the 1522 running on the latest version of DSM. It's also running on that dual core 2.6 gigahertz AMD Ryzen 1000 series CPU, the R1600, and the system's got that 8 gig of memory that it arrives with by default. And as you can see, we've got that adapter there for that 10G adapter, and later on in the video we're going to go 10G to 10G there. Now, obviously, if I'd had an 8 bay or larger here in the studio and more drives, I could have given you a better understanding of the performance of this. But as I've only got 4 of the 22 TB drives, and you guys have been asking, dare I say, clamoring to know what the performance these drives can give you, hopefully today will give you some indication of that. Now, in order to set up today's test, I could have used a mapped network drive. A mapped network drive, for those that aren't aware, is when you go into the storage system, you create a shared folder, and then you can just add it to your list of available drives as a remote drive. Now, mapped network drives do perform well, but they don't perform as well as other systems when your localized test machine, in this case a Windows 10 Pro laptop, wants to see it more natively. So if I was to create a mapped network drive, if I'd gone into the Synology Assistant application, found the NAS when it's listed here on screen, right click and mapped a network drive like I have before, that would allow me to add the drive, but it wouldn't give me the best and more native test results. It also would have eliminated some of the better test tools out there in the market that I might want to use in order to benchmark. And in today's video, I am going to be looking at AutoDisk benchmark. So in order to make the most of that test, what we want to do is create an iSCSI target and a LUN of storage. Again, ignore the operation failed. That's just when I was flicking between IPs. And as you can see, what I've done is not only create a target there, but I've also created a large LUN there, a 20 terabyte LUN. That is a big old bulk area of storage which we can now utilize, and in turn that allows us to create a native looking drive. That is, if you are utilizing the NAS and you want to use your third-party apps, you know, your OS, or you want to use tools for photo or video editing, it's recommended to use an iSCSI target in order to edit directly on the NAS, because it will allow host applications on your operating system to be able to see the NAS like it would an internal OS drive or a connected SATA drive. It makes the NAS appear as if it's localized, and that's what I've done there. Now, that iSCSI target has been set to thick provisioning. I've also removed any kind of authentication, so CHAPS, CHAPS, and in the iSCSI initiator, I've added the drive as you normally would expect, and I've created a target there and adding the drive. I've also allowed multi-IP path to enable an easier access path there, and to ensure that if the NAS is connected to via another system or service, it won't impede our results. So moving away from that, you can see the target we've done there. We've got our RAID 5. Later in the video, I'm going to format that RAID 5 and turn it into a RAID 0. Let's go back to those results from earlier, because as we've been talking, this system has been benchmarking those drives. And as you can see, as we go down the line, those performance there are not as high as we would have liked, are they? At the moment, we're connected via 5 gigabit Ethernet there over USB, but we are running a quarter of a gigabyte test file there, so we would have hoped to have seen results somewhere between 300 and 400, something we've not really seen here. Now, the reason for this is twofold. One, because we are using recording software, OBS, as you can see here on screen, and the result is that has an impact on our performance. If we open up the task manager, you're able to see here that some applications, such as Chrome for example, are very greedy when it comes to memory resources. However, when it comes to OBS, it's greedy on graphical processes and CPU utilization, which is exactly the things which can get hit quite hard during bench testing operations, particularly apps like AJA and Blackmagic. So in order to commit our tests, what I'm going to do shortly is stop recording screen and then do a barrage of tests on this connection. I'm also going to reset our connection if we go back into it, and we'll change our MTU to where we want it to be. So let's select that and select it back to our 9000. So let's reset our jumbo packet value there back to 9,000. And what's going to happen now is it's going to reinitialize with that adapter. It's going to reappear on our available network connections, and the drive is going to be reconnected to our list of available drives locally on our machine, as our 5GP adapter, as you can see there, is now starting to refresh with the updated network settings there. Now, if we make our way back to those results, I can also show you some results that were taken before we began recording here. So as you can see here on the left hand side of the screen, these are the results that were taken when we performed our test without the MTU upgraded, but not having OBS running in the background. Don't worry, we'll close those other processes. Now, if we overlap these results and put them side by side, you're able to see that the distinction in those results is quite substantial when we don't have OBS recording. Now, a number of you may keenly wish to highlight, why don't I use an external capture card? And that's right, I could have used an external capture card. And during testing and setting up for this video, I did try to use that external capture, but I still found that because I was still connecting that external capture to another device, it was still utilizing GPU resources to render a second mirrored screen, and it still impacted our results. So in order to give you the very best results possible in this testing, I am going to suspend OBS, commit a whole bunch of tests on the 5 gigabit Ethernet connection, show you those results, and then we're going to reformat the system to a RAID 0 and also use a 10 GBE connection, perhaps doing some mixed tests in between, and then go through all of those results later in the video. Because as you can see here, when we compare the results with and without OBS running, even if you don't address the MTU and jumbo packet results, the difference is quite astounding there. And whereas with OBS running, our results here were pretty small, barely getting out of the 2.5 GBE range. Without OBS running, we were exceeding 350 in places and getting very close to 400 on that 250 megabytes per second test format. We will be trying a gamut of different tests, and this should take me around about 2 hours. So I'm going to fast forward time now to the results for you guys. So stay tuned. For me, it's going to be a number of hours. For you, it's going to be a matter of seconds. Let's go. Okay, so we've completed our first barrage of tests, and let's go through those results, shall we? Because I did quite an extensive little number of tests, it has to be said. We covered all the way from a very small end there, starting at just a 64 megabyte file there, and going through it, we did see some quite consistent results. So remember, we are using a 5 gigabit Ethernet to USB adapter. We will be switching over to 10 GBE shortly. But as we can see, when we started here on the left with our 64 megabyte file there on that destination drive, we comfortably cracked the 400 megabytes limit there on read. We were still utilizing an internal SATA SSD for some of these operations, so there were slight bottlenecks there that we couldn't comprehend, but going all the way through there, write was comfortably at 370 and read was consistently capping at 425, which either means that those drives in that configuration of RAID 5 of 4 of the 22 TBs, that was kind of our upper limit, or we were hitting the capacity and limit of that 5 gigabit Ethernet to USB adapter. That's why we need to do our 10 GBE results. And even then, we can look at the IOPS. We're not going to be too concerned with IOPS because we're still talking about mechanical drives there. But as you can see there, the read and the write on that 64 meg file there, doing very well. We made sure to enable direct I/O because otherwise our results would have been all over the place. And if we make our way away from that, we can go to the next tier up, and that was that 256 megabyte file that we tested earlier on with OBS running there. And now, of course, we're running on the MTU at 9000 and without OBS for these tests. And once again, comfortably hitting that 370 write and that 425 read there across there. And moving forward, we retested the 1 gig file there, and again still hitting those same lovely high results. And moving forward, we went even higher, and this is where we went to the chunky files and started seeing there just on the 4 gig and 16 gigabyte test file over 10G, that performance there start to wane ever so slightly towards the 16 gig as we started oversaturating the cache of that drive. And that's something else we have to bear in mind with these tests, that we could be potentially oversaturating the drive and its cache by these enormous files when we're doing repeat file format testing there across the spectrum all the way down to 46 megabytes there on the graph transfer rate there. Now, again, the reason I went for Atto is we get a much more distinct breakdown of the results as we go all the way along. Case in point, I know I'm running OBS right now, but if we try to run AJA right now, and as you can see, we're running without disk cache enabled, we're running just a single test, single file read write. If we try to run that test, this is what happens. We see those results hitting 230 and 350, which is still good. But again, not only because of OBS, but also because of AJA doing its file format and its oversaturation of the cache, what we find when we try to run that exact same test continuously, watch what happens to the performance over time. Even ignoring the fact we're running OBS and bench testing those results too clearly. Sorry, I've got cat hair on my face from my cat. Fantastic stuff. But you start to see diminishing returns, and on those graphs at the bottom, you start to see that performance dip and wane as the cache begins to oversaturate, something that can be emulated a lot bigger, a lot easier with the larger file formats. But for now, what we're going to do is we're now going to make a transfer over to the 10 gigabit Ethernet adapter there. And I'm going to do that live on camera to give you some idea of how it's going to look. So again, as we do this, we'll open up the control panel to show you the network interface, because what's going to happen while I'm doing this is we're going to have the connection to the NAS severed. I've made sure that we've remained on that 169 10 GBE connection there, and as you can see currently it's showing 5,000 megs, and indeed if we make our way into the network manager, you're still able to see that we're using that 5 GBE Ethernet connection there. So what we're going to do now is migrate away from that. So the first thing I'm going to do is safely remove the 5 gigabit Ethernet adapter. So we're going to find it there, we're going to right click, and we're going to disconnect it there. So let's disconnect that drive, and then from there you can see it connected. We're going to remove. You heard that little beep there saying it's signified the removal. There is our connector, our 5 GBE out the way, and now we're migrating over to a Sonic Solo 10G. This is a Thunderbolt to 10 GBE adapter. First thing we want to do is connect the NAS cable. So that's already in there from our NAS. I don't know how well you can see that there on screen. And then we attach our Thunderbolt connection. Now we may need to restart the system in order to fully recognize this device. But what we do is we give it a brief moment to see if the LED labels kick in, lights kick in. We've heard that noise, which signifies that the system has now been recognized. And again, whether it comes into printers and devices, we'll have to wait and see. But if we come down from there, we can make our way down to the bottom. We can now see that Solo 10G adapter is now being recognized gradually, and we'll know whether we need to reset because the status won't show us 10G, but we can see the status indicator is giving us our 10 gigabit Ethernet connection there. On there, we can see that QSync there in the background has recognized it as an external device, and indeed, if we go back to that list of available devices, it doesn't list it on there because it still counts as a network adapter and not a USB device, but still now we're able to plug back in to that NAS there very easily. So let's go with that and log straight in with our credentials. Leave it signed in. It should allow us to sign into the device. What we can also do is make our way back into the network manager. From there we can verify if we're running MTU 9K. So again, go into configuration settings, go into the advanced, go into jumbo packet, and as you can see we are running the right configuration there, which is great to see. Come from that, next thing we want to do, we can hear the fans on my laptop start to ramp up a little bit there. Go into the network settings, go into the network interface, and we can see now that that connection earlier on that was showing 5,000 megabits is now 10,000 megabits, or 10 gigabit Ethernet there, still set to the MTU 9000 jumbo packet there. So we've got that set up, we've got our storage configuration, we can go into the SAN manager, and after this I will be formatting this config to a RAID 0, so we can have a basis of comparison, and then we're going to compare the results of our tests at the end of the video. But for now, what we've got our LUN, everything's healthy, everything's visible. If we make our way into the storage manager there of the local PC, we'll refresh it there. We're able to see that our 20 TB new volume is still visible. Indeed, if we make our way into the PC there, we can make our way in and we can see the new volume has appeared. We can check its identity very, very easily, and we're able to see that it is still running as that local drive that we had before at 20 TB. So we're all set up for the 10 GB testing. Once again, if we try to run a brand new test here with OBS running, it is going to impinge our results quite dramatically. I might even do a restart in just a moment just to be on the safe side, but just to put it into perspective, if we try to run that 64 meg transfer test there, let's run that now. And while it's doing that, we bring back our previous 64 meg test and put them side by side. You're going to see that OBS is going to make its impact. For a start, look immediately at the performance difference there of even just the very first write operation there between the two of them, effectively halving that overall number. So what I'm going to do now, once again, is complete a barrage of tests on the 10 gigabit Ethernet connection just to see if we can get a little bit more out of what the 5 GBE or connection can give us, or is it that 4 of these drives in a RAID 5 configuration has already kind of hit its cap, really, with regards to the RAID 5 over a 5 gigabit Ethernet connection. Again, I'm going to fast forward. For me, it'll be an hour or two. For you, it will be instantaneous. Let's fast forward. Okay, so we finished our test, and I'll be straight with you, I'm really impressed with the results overall. But before we make our way over to it, and again, just to give you a little bit of a teaser there, have a look at that. That is our 64 megabyte file, and we were maxing out that 10 GBE connection with a full gigabyte on read and getting pretty high into the 800 and 900 megabytes per second there on that 64 meg file. Before we go through the results, what I'm going to do is very quickly start setting up for our RAID 0 testing. And what we're going to do is dismantle our RAID 5 and then rebuild ourselves a RAID 0 and do our same setup with a 20 TB iSCSI LUN. So what we want to do is slowly start dismantling. So there's our original LUN. We're going to delete that there. And the system, while it's doing that, will allow us to multitask and go through the results while the system is doing the dismantling for us there, and we destroy that RAID configuration. But let's get some of these results here on screen. So the first 3 tests that we can look at there on screen, we have got our 64 megabyte file. We have the 1 gig there on that side, and in the middle, we got that quarter of a gig, 256 megabyte there. And as you can see, in terms of read performance, with only 4 drives in a RAID 5 on the 22 TBs, we were maxing out the 1 gigabyte, so 1000 megabytes per second transmission there of our 10 GBE adapter. On right, we can see that as we got into the denser files, we had to still deal with the element of oversaturation. And as we got deeper and deeper with the bigger file type, starting at the 64 meg into the 256, and finally into a 1 gigabyte test file, the performance there started to dip ever so slightly. And indeed, at the 256, that's when we started to see it kind of start to come down there. And if we make our way into the 1 gig file there, we started seeing 500 and 600 megs, which are still really good numbers for 4 drives in a RAID 5 configuration, which only goes to show the enterprise build quality of those 22 TB drives. Before we make our way into the next round of tests, as you can see, that iSCSI LUN has now been destroyed there. And what we can do now is make our way back into the storage area there. And as you can see by now, that drive has disappeared. And we're going to keep the iSCSI target already listed on the iSCSI manager there, or the iSCSI initiator. It's there on screen. We'll keep that there for later on. But now we're going to make our way into that storage area, and now we're going to destroy that storage pool so we can create ourselves that new RAID 0 configuration. This will completely nuke that RAID so we can create that RAID 0. So we're going to remove the pool, erase all of the data, put on that password, and then we'll start getting ready for our RAID 0 build there in the background. Now, carrying on with our test results, we can have a look at the biggest file formats that we looked at there, and these are the 4 gigabyte file and the 16 gigabyte file. Now, On the 4 gig file, we can see here that the system still managed to maintain that 1 gigabytes per second read, but it was only when we got to that enormous 16 gigabyte test file in Atto that we started to see a tiny dip in the potential performance of 10 GBE on this RAID 5 configuration, with the megabytes per second there starting to ebb into the 8 and 900s in the middle there, and also as we go into the denser file types cross-reference with the 16, hitting the 600 and 700 megs. Now on the 4 gig test file, as we can see there, we managed to continue in read the 10 gig file size there, with performance generally sitting conventional use at around 600 or 700 megabytes per second, peaking at 786 megabytes. So still fantastic performance for this kind of file scale in Atto disk benchmark, using just 4 drives, all of which are those 22 TB drives. Now, right now, it's going to start unmounting and destroying that RAID 5 pool there. So what I'm going to do now is fast forward to after I've created our RAID 0 configuration, and we're going to repeat the entire setup exactly the same way. We're not going to revisit 5 gigabit Ethernet, we're going to stick with 10 GBE, and what we're going to be doing is those exact same Atto benchmark tests in 64 meg all the way up to 16 gig, and we're going to compare and contrast those against the RAID 5 configuration so we can see the performance differences. We've already kept a record of all the tests thus far, so we can compare them side by side, but for now I'm going to fast forward to the completion of our RAID 0 creation. Okay, so we've initiated and created our RAID 0, and I've performed a bunch of tests just like we did before. As you can see here on screen, we've got our iSCSI recreated here on that LUN there, or the LUN on that iSCSI target, I should say there, 20 TB already provisioned. On top of that, we are still connected via 10 GBE on the 10 gigabits per second connection, and if we make our way into the SAN manager, the storage manager, you can see that our RAID 0 is indeed complete there. Although I will highlight that the volume is being optimized right now, which is kind of like a defrag, but that is constituted since creating that, so don't worry too much about that. But as you can see, we've got our RAID 0 configuration all up and running. Now on the local side on my PC, I've done a bunch of stuff. Obviously, I've attached that iSCSI there, that iSCSI LUN there via the target, and indeed recreated it and re-added it there on the iSCSI initiator. Bring that back up there. And of course, we've got that network connection already established, and unsurprisingly, if we make our way into the properties, we're able to see immediately, once again, I know I showed you this just now, but bear in mind it was quite a few hours ago for me, we've got that iSCSI created, the network IP on the MTU 9000 for the jumbo frames. Now, I committed my tests, and I've got to say, it might be that because of the file optimization not being completed yet, our performance wasn't quite as high as I would have liked, but I will say that certainly write performance is seemingly better. To put that into a little bit of perspective, let's put that down and we'll start running through our results. So first and foremost, let's get up our 64 megabyte test there. So as you can see, 64 megabytes there. Once again, fully saturating that 1.15 gigabytes there on the read, the write. And if we open up to our earlier testing from earlier on in the video, you can see on the right hand side of the screen there, this is the RAID 5 configuration. So same 10G connection, same file size there on Atto. And if we overlap them slightly, you're able to see, putting them side by side a little bit there, that in terms of write performance, the RAID 5 seemingly did better on this smaller file size. And when it comes to the consistent read, they were largely comparable. So next up, we'll make our way into a 256 megabyte test file there. Let's bring that up there. And again, you're going to see very similar results there. And the only real change you're going to see is as we go to the larger file types. But once again, as you can see, the consistent write was seemingly higher on the RAID 5, but the read was pretty much like for like, and the earlier transfer speeds for the smaller file size seemingly did a great deal better on the RAID 0 than they did on that RAID 5 there. So we'll move that down there and go to the next leg. And again, now we're moving into, let's bring that up from the top. We're moving into the 1 gigabyte territory. There is our 1 gig file. And again, RAID 5 for RAID 5, overlap. And this is where we start to see that downturn. Look at that write performance there at the 1 gig level. Although through the middle parts there it was kind of trading blows, when we get to the larger chunk formats there, we can see that the performance was better on the RAID 0. It's always seemingly better at sequential, but again in both cases read performance largely saturated throughout. But again, just seeing us a little higher, little tweaked higher there on that RAID 0 over the RAID 5 there. And this is something that gets amplified once you go to the larger bay storage, you know, your 8 bays, your 12 bays, your 24 bays. But also bear in mind that RAID 5 isn't as complex as it once was when it comes to the operational hardware of a lot of servers these days. So again, the disparity between RAID 0 and RAID 5, you really have to push the boundaries of your storage in order to make, you know, any kind of meaningful difference there between them. So next up, we've got the 4 gigabyte test file there, so let's bring that up, and 4 gigabytes there, like for like. Again, we're starting to see that same kind of now pattern emerge as we go into the larger sequential data types. We're seeing consistently higher there, between 50 and 100 or so megabytes per second, like on each tier there on the RAID 0, than we are on that RAID 5 test from earlier. Both are largely saturating the 10 GBE in terms of read sequential, but again, a consistent saturation there on the RAID 0 than over the RAID 5. But it's still nonetheless still great performance from just 4 drives in a RAID environment there over 10G. And finally, we look at the largest capacity test file that we went for there, and that is of course the 16 gigabyte test file there, which we put on like for like. And popping them side by side, this is again that example of how RAID 0 and RAID 5 compare, because RAID 5 obviously needs a little bit more work in the back end to get it done and calculate that parity, and the larger the file types, the harder it becomes to calculate that parity lickety split. And as you can see there, RAID 0 having no parity considerations, unfortunately that meaning no safety net, still means that in terms of write performance we see consistently higher numbers as we go later on. The earlier numbers are trading blows easily because of the size of the packets, but then when we go to the sequential read performance, again much higher performance in the RAID 0, but still nonetheless doing a great job of saturating either fully or getting pretty darn close on 10 GBE. So what have we learnt in today's video? Well, several things. Number one, we've learnt that 22 TB drives most certainly work in the 1522. And not only do they work, you only need as little as 4 of them to comfortably saturate 10 GBE and hugely oversaturate 5 GBE. Next, what did we learn? We've always known that RAID 5 and RAID 0, when it comes down to it, RAID 0 gives you that higher performance at the expense of parity. But it's only looking at these graphs that we can see, thanks to 10 GBE external output, just the sheer difference it makes when you're dealing with larger file types. And if you're dealing with smaller file types and the block sizes and just the average data you're going for is smaller, then you will find that the RAID 5 and RAID 0 performance then reaches kind of a middle ground there. So that might be something useful for you guys, knowing what file types and file scales you're using if you're thinking of investing in larger drives or 10 GBE and considering the RAID configuration there. And of course, the last thing we can take from today's video is that the 22 TB drives and indeed the Synology system combined together in traditional RAID configurations is more than enough to get that 1000 megabytes per second in either direction when needed in the right scenarios and the right setup for photo and video editors there. There's a lot to take home from today. And again, thanks so much for WD for supplying the drives. I am absolutely mullering these. I've only got them on like a 2-week loan, and I apologise for how much damage I'm going to do to these drives. I'm going to be doing some further tests with these drives and this system. I might revisit this test on the RS422, another NAS that takes advantage of that little upgrade there, so stay tuned for that. And of course I will be doing some QNAP testing as well, where I will be looking at a 464 series in a very similar test to this, but looking at its own handling of these drives in its own storage system. And the last thing I will add is these performance figures may have improved the tiniest pinch if I'd allowed and had enough time during this loan to allow optimization to complete. I don't think it would have made a tremendous amount of difference because I'm not using an array that is heavily data filled already, like a defrag would, but still nonetheless, when we do our next test, I'll hopefully address that there as well. But otherwise, thank you so much for watching. I hope you've enjoyed this video. It's been very tech heavy and a lot more statty in your face, but I hope if you've been looking for an answer to questions on the 22TB Synology 10GB upgrades and throughput, I hope this video helped you. Click like if it did and subscribe to learn more as we pursue this subject and data storage and network storage in general. And if you need help choosing the right solution for you, use the free advice section over on NAS Compares and the free community forum over there on Ask NAS Compares, linked in the description. There's also links to the reviews for all of the products used today in the description below, and of course where to buy them on Amazon so you can support the channel. But other than that, I will see you next time.